Kia ora and welcome from the Explain IT team. I'm Gary and thanks for taking the time to view this short presentation on two of our pieces of work. If you want to jump to a specific part of the session, you'll find timestamps in the comments below. Explain IT is based in the land of Kiwis and sheep and has a long history in working with learning challenges with numbers. We're a small team of four living here in New Zealand, while Philip lives in Adelaide, Australia. Global population percentages for Dyscalculia vary quite wildly. Our figure of 12% may sound a little high, but we're up for a debate on that. If we add a very conservative figure of 50% of the global population experiencing maths anxiety, then we begin to see the extent of the problem, which is poorly supported by resources available to all. If we focus on dyscalculia being the centre of the problem and expand on that with just a few of the common symptoms such as counting, spatial awareness, working memory capacity, number skills, calculation skills, and measurement skills, and then add a layer of how these symptoms are seen, then the big picture becomes clearer. So let's just take a second to look at an example of unrecognised dyscalculia. You may recognise Hannah as part of our team from the slide earlier. Hannah is put in the highest maths class during the school years. She excelled in other subjects but struggled in all aspects of number work. She was repeatedly assessed for dyslexia and always passed with flying colours. The general conclusion was Hannah is basically lazy. Then at 23, Hannah had a PA position in the primary school she attended when she was younger and enrolled in a business management course. Her strategy of avoiding any maths tasks till the last minute was becoming a problem and was about to catch up with her. Her assignments required her to organise a conference, things like booking air travel, accommodation, catering, guest speakers, etc. And the numeracy requirements of this assignment were broad and complex. And so began the story of Hannah's pink calculator. I naively thought, this is easy. I'll teach her to use a proper calculator with a whole lot more functions. How hard can that be? Well, it proved to be impossibly hard quite quickly. In my role as student support mathematics, I gained an increasing awareness of other students with similar problems to Hannah and began thinking of how the calculator layout and user interface could be altered to assist this group. Similarities in the way I was altering the calculator emerged, and with a combination of tools and Twink, mods could be made to personalise the calculator for each person, and it worked. The evolution from the pink calculator to Dyscalculator has taken around 15 years, to the point where now Dyscalculator is available in 72 countries as a free web-based version, plus an app for both iOS and Android devices. To give Dyscalculator a try, visit us at dyscalculator.app. You will also find a video introducing you to the project and showcasing the unique features of the Dyscalculator. It's an absolute pleasure to regularly receive messages from across the world. This one, for example, where a concerned parent has been able to get Dyscalculator okayed for use in exams in Wales. I'm also aware of a similar action that is underway in England at present. Also messages from supporters of ours in the UK. We're entirely self-funded and are hoping to keep the web app freely accessible. As mentioned, Dyscalculator is also available as an app for both Android and iOS. If you're in a position to purchase an app, you help us cover some of our ongoing costs and future development. If you like what you see, please follow us on our social media channels for updates and share Dyscalculator with your networks. And now for a brand new tool. This forms another layer on our Dyscalculia wheel, a layer of how can we check for this? It involves tasks highlighting challenges in the various areas of the wheel and is aligned to school curricula documents, workplace documents, and home-based needs. The tool is suitable for learners from age 5 years to any adult age. Welcome to Numbers Explorer. This is our brand new online, fun and user-friendly screening tool for Dyscalculia. Over the next few minutes, I'll take you through a brief flyover of Numbers Explorer. Please bear in mind that we are in admin and demo mode here. Each person engaging with the Numbers Explorer screener will see a more simplified screens without admin functionality. I have an access code sent to you by our administration team, which will allow you access to the various tasks in Numbers Explorer. The first screen you'll see will have your name at the top. Where it says Welcome Sam on this picture, it will have your name, whatever it is, so it'll be personalised towards you. These number games will take about 20 minutes, so about 20 minutes for each person to complete Numbers Explorer. It seems to be the average times we're seeing at the moment. Numbers Explorer can be used as a full screen. We advise this. It makes the whole interaction a little bit easier. You'll see here a screen with other instructions. These are available to be read to you as well. So this is the first task we have in Numbers Explorer, and it's a task we use for everyone. So regardless of age, everyone does this task, and it's called Bubble Pop. And you can see from the little demonstration there where the requirement of the task is to basically pop a bubble that appears on screen. Let's just start it and give you a brief demo. So you'll see the bubble appears. It starts quite large and starts moving around the page, getting smaller and smaller. So what we're looking at here is a couple of things. For younger learners, we're going to see some fine motor skills, and for everybody, we're getting a base reaction and processing time. This is important, and it will vary because of different devices we're using to access Numbers Explorer, and again, the ability of the person to either use a touch screen or computer mouse-based screen. At the end of every task, you'll get a message and a prompt to go on to the next screen. So another task in Numbers Explorer is a task of working memory capacity. We call it honeybee, in which bees will leave a hive and come back again at another task. Let's just start it and see what happens. So you'll see here how the different cells are coloured the darker green, and the requirement is for the user to click on the cells in the same order that they appear. This task will go on from starting at 2 cells, going right through to 7 cells. And it's very, very important to notice that all of the messaging you're getting as this task is occurring, as with any other task in Numbers Explorer, is extremely positive. The person using Numbers Explorer will not be aware when the task ends, goes on to another task. However, behind the scenes, Numbers Explorer will allow 3 incorrect entries before it moves on to the next task. You'll see here now 4 honeybees. So the next task for honeybees is a reverse of honeybees. We call it BB buzz. If you look at this task, now the requirement is for the operator or user to click on the cells in the reverse order. So the last bee to return is the first bee to click. Let's just have a look at how that works. You'll see on the reverse honeybee, if the cells are clicked in the same order as they were clicked on the original honeybee, you will find a message coming up to remind you that the reverse order is what's required here. So the last bee to return is the first bee we click. Let's just have another look. Now you see the last bee to return is the first we click. Like the prior honeybee task, this one will carry on up to 6 honeybees, and we're doing the reverse order because it increases the demands on the working memory, and we'll commonly see in our data some quite distinct differences of the forward and backwards versions of the honeybee. So another task we call matchups. You may be more familiar with the word subitizing, but we use matchups because it's a word that's easier to understand perhaps for younger learners. Let's just have a look at how this works. So you'll see a series of dots on the side of the page here. In this case, there's 6 dots and the digit shown is 6. So we would choose then the green thumbs up as the solution to that. This will continue on, and we've found that the green thumbs up, the red thumbs down is a very, very universal symbols for correct and incorrect. So those have now become quite an essential part of our screener. This task requires us to identify a position on a number line. Let's have another look at this task. So you'll see in this case, the number 9 is what we're required to show. And by grabbing the arrow and dragging it down and sliding it along the number line to about the position that we think 9 is. At that point, we're clicking on Analysis, Image, and going on to the next challenge. You'll notice here that as this challenge continues, the arrow gets smaller and so does the degree of error that's available. So we start to see at which point the operator or user of Numbers Explorer starts to lose their place a little. Very, very important information for us. Again, you'll see a positive message at the end of each task. In this task we've titled Mailbox, we're looking for place value skills. So we've made a little story about here how the numbers have fallen off the mailbox and the mailman has to put the numbers back on. Let's just start that and see how it works. So in this task, we're given a number in its written form, in this case 59. The learner then needs to pick the correct number from the number line at the bottom and place the digits in the correct order as to their place value. When the learner is satisfied with that, click on the letterbox and move on to the next section of numbers. Mailbox starts with 2-digit numbers, then goes to 3 and later to 4-digit numbers. These are allocated to age and school year of the people using the task. Cut that bit out. One of the common symptoms of dyscalculia is the inability to read and operate with time. Alarm Alert is a task that we're using to highlight any particular issues with time. If we start, then let's have a look at how this works. So you'll see there's a number given in an analog clock form at the top of the page. The learner then must click on the correct time in the digital form of the 3 times or 3 options of times given at the bottom of the page. We now need to convert back from analog to digital time. So this task will do exactly that. Click on Start to see what happens. You'll now see a digital time at the top of the page and the 3 analog clock versions at the bottom of the page. Again, the learner needs to click on the correct analog clock that matches the digital time at the top of the page. We now get into some arithmetic type tasks. You can see we've called up, and away, which is an addition task. If we click on Start, we can begin this. You'll see now we're given a sum and the opportunity to say green, yes, it's right, red, thumbs down, no, it's wrong. So in a matter of clicking through those, you'll see it's only single digit addition at the present, and it will stay that way throughout this task. And again, you'll see the positive reinforcement that the task has been done. Back to TAC involves slightly more varied number of problems. Let's click on Start to see that. The main difference here is that through our learnings with Numbers Explorer, we've added a skip button at the bottom. This has proved very, very useful in our data collection in that it takes away the yes, no option or correct, incorrect option and gives us a third option of, hey, I'm not sure and I don't really know that. So valuable in our data collection for Numbers Explorer. Mind the Gap gives us slightly more complex mathematical problems. If we just click on Start, we can show you some examples of this. You'll see now the solution is part of the sum rather than the answer. So we're using the same number line at the bottom there to move the digits or digit that we think is the correct one to move into the box to complete a correct equation. You'll notice also we have the skip button available. And you'll see also we're doing some division and multiplication. One of our final tasks is called Brain Booster. This is designed for older learners. And what we've found also quite interestingly is that dyscalculics like to have a go at this regardless. And hats off to them for their bravery in that. But let's just start and I'll show you a little. You'll see here there's a percentage problem, for example, where we need to look at what percentage of the days of the week exceeded 20 degrees. What is angle A? 20,020 looks like what? You'll see some of these numbers we've put in here are purposely selected because they're quite difficult, and we know they're quite difficult for dyscalculic people. Which fraction's biggest and which is smallest? Again, the skip button is available on all these tasks, but it's really interesting how many people actually have a go at it and try to work out these solutions. Fractions of the box is shaded. What fraction? Conversion of centimetre, to this case, to millimetre. Some probability, heads or tails. What is 0.75 as a percentage? What is 39% as a decimal? What is 1/5 as a percentage? And again, with these tasks with the older learners, we have the ability to add in a timer. This timer is, you may think is quite mean, but it actually loads up in the anxiety levels of the learner, and we can see at what point the learning starts to become challenged. You'll see here the counter is available. You can see here with mailbox exercise, in this case it's on 3-digit, and you'll see the timer going on the side of the screen there. This really ups the anxiety levels and causes some quite different results in the learner's capabilities to complete the task. So bearing in mind we're looking at our admin screen here, but you can see there are various options available to us as we set up Numbers Explorer. You'll see initially we're available in English and German. We can just click onto German and I'll show you that's available in German. And we're considering other languages at the moment. You'll see the ability to turn on and off the show countdown timer. As we've seen or will see in this video, the countdown timer is available on all tasks. The list of activities, you'll see there seems quite a long list of activities. These are then be able to be divided up into sub-activities. And bearing in mind that each learner will be assigned a different set of activities. So that usually is gauged by age of school year. So that year 5, or perhaps let's start again, a year 1 learner would get totally different activities to a year 14 learner. When you've completed Numbers Explorer, this is the message you'll get on the screen. However, it's not the end of the Numbers Explorer experience. Following Numbers Explorer, we offer reports in the form of traffic light reports, being green, amber, and red for classes of people. And in this case, if we were seeing this, the red learners, or the numbers of learners that we had allocated a red report to, we would offer a more in-depth report. We also offer conversations with key people and links to other resources we have. If you have any queries or suggestions around Dyscalculator or Numbers Explorer, please reach out to us. We really appreciate your feedback. Thank you very much for your time, and greetings from Aotearoa, New Zealand.